Hello and welcome to the Math Studio. In this video, we're going to look at an example that involves converting a product of trig ratios, in this case, a product involving sines, into a sum or a difference involving other trig ratios. So in this case, we're going to be using the sum and differences of cosines. To prove left-hand side equals right-hand side. So let's have a look at this example. Show that sine of 15 degrees, sine of 75 degrees equals 1/4. Now, if you wanted to just sort of prove it to yourself or at least evaluate it for yourself, so sine of 15 degrees, sine of 75 degrees, we get 0.25 and that's fine. However, we need to prove this. Now, here's the clue. When you have a product involving sines, so sine sine, or cos cos, so sine 15, sine 75 in this example, it's going to be involving, or it's going to involve a sum or a difference of cosines. Now, if you recall cos of A, in fact I might just write it here, or cos of alpha, say let's say plus beta, you end up with cos alpha, cos beta, minus sine alpha, sine beta. Okay. Also, cos of alpha minus beta is cos alpha, cos beta plus sine alpha, sine beta. So that means then that we need to subtract one from the other because we need to eliminate the cos alpha, cos beta component of the cos alpha plus beta or cos alpha minus beta. So we need to eliminate cos alpha, cos beta. So what we're going to do is I want to retain the sine alpha, sine beta. So I'm going to start off with cos of alpha minus beta, because that has a positive or a plus sine alpha, sine beta term. And I'm going to take away from that cos of alpha plus beta. And the reason for that is because cos of alpha plus beta has a cos alpha, cos beta term, so they will be cancelled, or one will negate the other, and they'll disappear so nicely. So you're going to end up with 2 sine alpha, sine beta. The cos alpha, cos beta terms will disappear and you end up with 2 of these sine alpha, sine betas. Now, we need to assign values to sine alpha, sine beta. So that means then that, and I might just write it here again, so 2 sine alpha, sine beta is equal to cos of alpha minus beta minus cos of alpha plus beta. So just to make it a little bit neater there. Now we just want sine alpha, sine beta on its own, since the original equation only has one sine alpha, sine beta. So divide both sides by 2. So we have sine alpha, sine beta is equal to half outside of cos of alpha minus beta minus cos of alpha plus beta. Now, at this point, we can assign a value to alpha and beta. So in this case, alpha is 15 degrees and beta is 75 degrees. So I might just write that here. So alpha is 15 degrees and beta is equal to 75 degrees. So sine of 15 degrees, sine of 75 degrees. And by the way, I can interchange those because it's a product. So I could have put sine of 75, sine of 15. It's exactly the same thing. So given that it's multiplication. So that's equal to half outside of cos of alpha minus beta. So that's 15 degrees minus 75 degrees minus cos of alpha plus beta. So that's going to be 15 degrees plus 75 degrees. Okay, so we'll just simplify that further. So that's cos of 15 minus 75, so that's cos of negative 60 degrees. And remember, cos is an even function, so cos of negative 60, that's in quadrant 4. That's the same as cos of 60, of course. So we could just represent it using the related acute angle. minus cos of 90. Cos of 90 is that's sort of a nice number as well, because cos of 90 is just 0, of course. So that's going to be equal to half times the cosine of 60 minus 0. So that's really good. And cos of 60 is half. Okay, that's an exact ratio. So that's equal to, hopefully I can, a little bit of room there. I might just move the board ever so slightly up there. And that's times half. So therefore, which is equal to 1/4, of course. Okay, so therefore, I'll just put it here. Okay, sine of 15 degrees, sine of 75 degrees equals 1/4, which is in fact equal to the right-hand side as required. Thank you for watching.